see my screen now?
Yes, sir, we can.
Okay. Shares your back, or just will wait a bit. Okay. So earlier we were discussing about the regular functions like polynomial functions, like say for example x square, x cube, these kind of functions, right?
Yes,
So
sir.
where the variable is here and it is raised to some constant power, right? Variable is at the base
Yes,
and
sir.
raised to constant power. It is the opposite when we talk about exponential functions. We discussed these also briefly, right? 2 power x, e power x, etc., etc. We discussed about the graphs also, right? These are
Yes,
called
sir.
exponential functions. These are very, very important. What we discussed earlier, that exponential function, the slope is actually proportional to the value of the function, right? Our rate of change is actually proportional to the value of the function, right? That is what
Yes, sir.
we have discussed here. Okay. Now, okay, we discussed this also, right? Exponential functions are one functions. They are continuously increasing or continuously decreasing, right? Because they are continuously increasing or decreasing, they are one functions, right? For two different
Yes, sir.
x's, there will be two different y's. Okay, ma? Okay. Because they
Okay,
are
sir.
continuously increasing or continuously decreasing, and because they are one functions, if you get something like this, then it automatically means 3x should be equal to 2x plus y, right? Because they are
Yes,
one.
sir.
In other cases, you might not be able to say that. So, for example, sine theta equals to sine alpha, something like this. We cannot directly say theta equals to alpha, right? So, for example,
Yes, sir.
this could be 30 degrees and this could be 150 degrees, right? Agree, ma?
Yes, sir.
Okay, so in
Agreed,
this
sir.
case, we cannot directly say theta equals to alpha. But if it is a one function, you can directly say. Okay?
Oh, okay, sir.
Okay, so for example, let's say x square equals to y square. That doesn't necessarily mean x equals to y, right? Because minus 2 square
Yes, sir.
equals to plus 2 square also. Okay. And
Yeah.
whenever it is a one function, then we can say these things. Okay. Okay. Now,
Okay, sir.
this is exponential function. Okay. We were discussing about radioactive decay, right? Half-life period, etc. Right? Or growth
Yeah.
occupation. This is interesting. Compound interest. In compound interest also we discussed. Let's say we have something like
Sir,
this.
no, sir. We didn't discuss compound
We
interest.
didn't. Okay. Now we'll discuss. Shreyas, you can hear
Okay,
now?
sir.
Yes, sir, I can.
Oh,
I'm
okay, okay.
hearing.
Let's say we have this case only, right? He's taken some $1,000 and there is 9% interest rate. What does that mean? At the end of the first year, the interest would be $90. And what is the principal amount? What is the amount that will be there? This 1,000 plus this 90. Agreed, ma?
Agreed, sir.
Agreed. At the end of the
Agreed,
first year,
sir.
9% per year, right? What does that mean? It will become 1,000 plus 90, right?
Yes, sir.
Right. At the end of second year, what will happen? Again, 1,090, 9% of this 1,090, right?
Yes,
Agreed?
sir.
Yes, sir.
Okay, so then basically at the end of first year, what will this 1,000 become? 1,000 plus 9% of this
90.
thing. That is 1.09, right? 1.09 into, okay. What does this mean? 1.09 times 1,000, right? At the end of first year, right?
Yes, sir.
Now at the end of second year, what will that be? This times again 1.09, right?
Yes,
Agreed,
Yes,
sir.
sir.
ma? At the end of second year, that is 1,000 times 1.09 square, right? At the end of third year, it is 1,000 times 1.09 cube, right? Agree.
Agreed, sir.
At the end of 10 years, it is 1,000 times 1.09 whole power 10, right? That is the basis
Yes.
of compound interest, right? Now, In
Okay,
compound
sir.
interest, there are other types also. Let's say this interest accumulated. Sometimes you say that the interest is compounded monthly or compounded annually. Did you hear this word? Compounded monthly, compounded annually, etc.
No, sir.
Okay. I'll give you an example. Okay. So let's say $1,000 is the initial amount. Okay. Now 10% is the yearly amount. Okay. This
Okay, sir.
10%, if you are adding at the end of the year, what will the amount? It is 1100, right?
Yes, sir.
Agreed. Now instead of adding 10% per year means 5% per half year, right?
Yeah, sir.
Agreed. 5% per half year. Let's say you are adding 5% after every half year. Will that be 1100 or will it be higher? Will it be lower? You understood my question?
No, sir.
Okay, so 10%, one option is adding 10% at the end of the year. That becomes 1100. Or adding 5% at the end of 6 months. What will that be? This times 1.05, right?
Yes,
Yes.
sir.
After 6 months. Now, adding again 5% at the end of again 6 months. Will this number, you understood what we have done here? We added 5% at the end of 6 months, and at the end of second 6 months, again you added 5%. Agreed?
Yes, sir. Agreed.
So this is 10% at the end of full year. Shreyas, you are also clear, ma?
Yes, sir, I'm clear.
Okay. So one is adding 10% at the end of the year or adding 5% two times. Which one will you
Yeah,
prefer?
yeah.
Which one? If you are taking the loan. Okay. Which
Sir,
one?
10% for the entire year.
If you are taking the loan, right?
Yes, sir.
If you are giving the loan,
Sir, 5% for 6 months.
5% and 6 months. Why? Because you will get greater amount
More
here,
cap.
right?
More
1.05
profit.
square,
We'll get profit.
1.05 square is greater than 1.1, right?
Yeah, yes, sir.
Agreed, no?
Agreed, sir.
Yes, sir.
Okay. So now the bank will always prefer this case, right? If I am the customer, then bank will always try to give in this way, right? Though they will say 10% per year, they'll rather say in the second class they'll say compounded every 6 months. This is called
Yes, sir.
compounded every 6 months. Okay,
Okay, sir.
understood. Let's say if it is compounded every 3 months, let's say, then what will this number be? Then 1000 times compounded every 3 months. That means 4 times it will compound, right? 1.025,
Yeah.
again 1.025, like this, right? Again
Yeah, 4
1.025, 4 times, right?
because 12, yeah.
Right. Every 3 months you are compounding, right? This is after three
Yes, sir.
months, after 6 months, after 9 months, after 12 months. This number would obviously be higher than this number, right?
Yes, sir.
Agreed.
3 months is going to be higher.
But still the interest rate, they will call the interest rate as 10% per year only. So
Oh,
the thing is 10% per year, compounded yearly is one case, compounded half yearly is another case, compounded every 3 months is another case. Okay, understood no?
oh,
Yes, sir.
One second. Okay, compounded every 6 months, every 3 months is different, right? So bank will
yes,
always try to compound it in as small time period as possible, right?
yes, sir.
Let's say the other case. Let's say okay. So then if it is compounded every year, what does that mean? That means simple interest after the end of 1 year will be equal to compound interest at the end of 1 year, right? If it is compounded
Mm,
every 6 months, that means compound interest will be higher, right?
yes, sir.
Agreed, man. Let's say, so now what we are doing, what exactly we are doing is, do you agree with this formula here?
Yeah,
Okay, so
yes, sir.
this R is the yearly rate. Let's say it is 10, and 4 times you want to compound, then 10 by 4. This is 0.25, right? It
Okay,
is
sir.
2.5% or 5%. In this case, it is 5%, 2 times. Then how many times you are doing? It is you are raising it to the power 2, right? In 1 year,
Yes, sir.
if you are you want to calculate 2 times, then this NT, what is NT? Number of how many years? and how many times per each year. Let's say t is 1, then this becomes 2, right? Let's say if this is 3 years, compounded every 6 months. What does that mean? To the power 6. 6 times you will multiply, right, ma? And each year, what is each 6 months, what is that? That 10% by whatever.
Sir, will the
How
N
many
be 6 or
times?
T be 6?
Agreed, no? You agree with this formula, right?
Sir, will the,
Agreed, sir.
sir, will the
Agree.
N be 6 or T be 6?
What, ma?
Sir, what will be 6? Will the N value be 6 or T value be 6?
Okay. Let's say what we are saying. Okay, let's take the special case. R is 10%. Okay,
Okay, sir.
per year. Okay.
Okay.
Now
Okay, sir.
compounded. Let's say compounded every 6 months. What does
Okay.
that mean? Compounded. That means how many times you are compounding? 2 times in a year, right? So that way it will become
Yeah.
10
Okay.
by 2. This n is 2 then, right? Compounded
Yes,
every
sir.
6 months
For
means how
R,
many
we
times?
directly take a string,
What,
or
ma?
we should like change the.
No, you can
Sir, for
directly
R,
take. No, you can directly take. You can directly. This is I am just trying to
oh,
explain what exactly this statement is. Okay, you can directly
okay,
do.
sir.
Instead of saying 6 months, he is saying 2 times per year. It doesn't matter, no. So if it is 10, two
Yes,
times
sir.
per year is 10 by 2. Okay. And 2 times per
Okay, sir.
year, that is for 2 years, let's say. Then 4 times you will multiply this. That's it. Okay.
Okay,
Okay,
sir.
sir.
This is what he is saying. Okay. Now, uh, and one interesting thing. Okay, what is interesting thing? And we just realized that if you increase the number of times, the amount will increase, right? Okay, let's say for example, if 1 year interest is lesser than compounded 6 months is lesser than compounded 3 months, likewise, right? Now
Yes,
take
sir.
this special case. Now 9% interest rate. Okay, compounded yearly we have figured out, right? Compounded yearly we got some number. Now compounded every quarter, then we have got this number. Okay, this is the interest. Compounded every month. Obviously, this number should be higher, right? The interest
Yeah.
should be higher
Yeah, yeah.
at the end of the year. Then if you make it a week, that should be even higher, right? If you make it a day,
Yes,
that
sir.
should be even higher, right? Okay. At the
Yeah.
ultimate, what you can do, you can make it every moment, right? Every second or every split second, right? Like this, right now.
Yeah.
Okay. So now what exactly we are doing? This year we are breaking into 4 parts. Year we are breaking into 12 parts, right? Agreed. At the
Yes,
end
Agreed,
sir.
of the
sir.
year only we are still calculating. Here that interest rate we are breaking into 12 parts and multiplying it 12 times. Right?
Sir,
The
instead
interest
of
rate
1 year, sir,
tell me,
instead of amount of 1 year, if it was 2 years, then we do 12 into 2, yeah?
12 into
At
2,
the power.
exactly. 12 into 2. How many times you are multiplying? You are multiplying obviously 24 times, no?
Yes, sir.
Okay. So now what is happening? Now you can observe this
And then
as
will it be 0.09 divided by 12, or will it be 0.09 divided by 24?
divided by no, divided by 24 means what? You are compounding every 15 days. Understood?
Okay, sir.
Okay,
Yes, sir.
divided by 24 means what? It is not compounding every month. It is compounding every 15 days.
Sir,
Okay,
so if the number of year changes, only the power will be different. The
the
other
power
all
will
will
be
be same.
different. So this is what is this
Okay.
this one? This one is what is your compounding? Is it monthly? How many times you are compounding in a year? This means, right?
Okay,
Okay,
sir.
sir.
This 12 is what?
Yes,
How
sir.
many times you are compounding in a year? 52 times you are
Okay.
compounding in a year. If it is 10 years, then it should have been 520. Okay?
Yes,
Okay.
sir.
I
Okay.
get it now.
Now, see, if it is an hour, how many times you are compounding? There are 8760 hours in a year. So that should be this. Okay.
Okay, sir.
There are 365 days in a year. That's why daily interest rate. If yearly it is 9%, 9% by 365. That should be your daily interest rate. And you are compounding it for how many times? 365 times. Okay, ma? Now,
Okay,
Okay.
sir.
one interesting thing that you can see here is as this number is increasing, this number should increase, right? Agreed?
Yes.
Agreed, sir.
As this number you are compounding way more frequently, the amount will increase. But we are seeing that these numbers are getting close to certain number, right? This is actually getting close to this. The later decimals will change, but first two decimals are not changing. Okay, ma?
Okay, sir.
Okay, so this is very important for us. Okay, as this number is
Okay, sir.
forever increased, okay, forever increased, this number approaches some value. There is a limiting value that is of importance for us here. Okay.
Fine,
Okay,
sir.
sir.
Okay, so now let's take a general case. Okay, this is a general case. Okay, r equals to 1 instead of 0.09. Let's take a general case. Okay, Understood?
Okay,
No,
sir.
this is a general case. Here, interest rate, let's say the interest rate is, let's say, 1. Okay. And in time
Okay,
periods,
sir.
we are taking a general case of this. Okay. We have even removed this. We are taking this as 1 and this n and this n. Okay. Now, what we have realized, as n is increasing arbitrarily, this value is approaching certain value. Right. We have just figured out. Right. Okay, if this is approaching
Yes.
some value, that will also approach some value. If you pick a calculator and do this, if you do this calculation, this will approach this value. Can you see this?
Yes,
Yes,
sir.
sir.
Right. When n equals to 1, obviously 1 plus 1, 2, 2 power 1 is 2, right?
Yes,
Yeah.
sir.
Okay, when n equals to 10, this becomes 1.1 whole power 10. If you do a calculator, you will get this number, right? 100,000, whatever, whatever. If you do all this calculation, this number is some approaching some number. Okay, this is what we call it as
Okay, sir.
E. Understood?
Yes, sir.
Okay, so that's why it is. This is called the exponential expression. This one. Okay, 1 plus 1 by n whole power n. When limit n tends to infinity, this becomes actually equal to e. Okay, ma?
Okay,
Okay,
sir.
sir.
As you are increasing n arbitrarily, what exactly is happening? So now this is a special case of 1 power infinity. Agree? When n is becoming very big, what is this becoming? 1 plus almost a small number, right? and
Yes,
Okay.
sir.
and n is becoming infinity. So this is actually equal to 1 power infinity, right? Indeterminate form.
Yeah.
Okay. So this is the case that we were discussing about. Okay. 1 power infinity, it need not be, it could be anything, right? Depends on the situation. In this situation, what is it? It is approaching this number. Okay. If you do
Oh,
1 plus 1 by n square whole power n, then it need not approach this number. It might be some other number. Okay. Or
okay,
if you
sir.
do this 2n here and n here, this need not be this number. Okay. Only in this
Okay.
case,
Okay, sir.
1 plus 1 by n whole power n. In this case, it is approaching this number. Both and the other cases, say for example, what you are discussing now, 1 plus 1 by 2n whole power n. This is also 1 power infinity, right?
Yes, sir.
But this need not approach e. This might approach some other case. In this case, it is approaching e. We call this number, this is an irrational number. We call this as e. Okay, ma? Now,
Okay,
with
sir.
this, our entire story starts. There are a lot of applications about this e. This e is an irrational number. That means what you cannot express it in p by q format, right? Irrational
Yes,
number.
sir.
Okay, but though it is an irrational number, this has got lot of significance. Okay, which we'll understand shortly. Okay, e power x, you know this function, right? E power x, we discussed that it is some function, it grows like this. Agreed, no? Okay, and E is some number which is around 2.7. Okay, ma? You just remember 2.7.
Okay, sir.
Okay, now we discussed about this graph also, right? E, this is blue line, and 3 power x should be above E power x, and 2 power x should be below E power x. And the opposite
Will you
happens
try?
before 0, right?
Hmm.
Agree, no?
Agreed, sir.
Okay, now another interesting thing. Okay, so let's say we were discussing about 1 plus 1 by n whole power n, right? When limit n tends to infinity. What will happen in this case, say for example? Okay, this is not 1 by n. This must be some other thing, right?
Yes, sir.
Okay, so what he has done, he has cleverly manipulated it to this way. Do you agree with this statement? You can write it like this, no? This he has converted to this way. Do you agree with this manipulation? Basically, what is k?
No,
K
sir.
is n by r.
Okay, sir.
Okay, do you agree with this manipulation now?
Sir, can you explain that?
Okay. See, he wants to write r by n. Okay, k
Okay,
is
sir.
n by r. Okay, if k is n by r, we can write it like this, right?
So is K basically a constant?
K,
Constant or
K,
something?
K is just R by N. That's it. N by R. Okay. What? No, no.
Like,
What
what's
we are?
like the significance of K? Is it just like a constant or
No,
something?
no, no. What we are trying to get this in the format of 1 plus 1 by N whole power N. That's it. We want to match
Oh,
this and this. Okay. Here it is
okay.
not this. Right. That's why we are trying to match this and this. Okay.
Okay, sir.
Let's say K is N by R. What will become N? N becomes KR. Right.
Yes,
If
sir.
K
Yes,
is,
sir.
that's it. Don't worry much about it. K is not any big thing. K equals N by R. Then what is N? N is KR. Right.
Yes, sir.
So that's what he is doing. N by R, if you write it as K, then what will N become? N becomes KR. That's what he has done. Nothing else. Okay. We can write
Okay,
this.
sir.
Now we agree, no? You can write it like this, right?
Yes, sir.
Right. Now this one, you can again this RT you can send it outside, right? A power
Sir,
mn is A
won't it
power m.
be 1 plus, or won't it be 1 plus 1 by k, or if n becomes k? Like they only left it as 1 by k.
It is 1
Are
by k
there 1
only, no?
by k?
See, R by n is 1 by k. R, see, this one,
Oh yeah, sir, I got it now.
you got it, no?
When you like, yes, sir.
And we
When you
did not
take
do
the
anything.
reciprocal, it becomes like that
We,
only.
we, we just we just called it something else. That's it. Instead of
Okay, sir.
calling it on when, let's say what we are saying is instead of calling it 2 by 3, we are saying 1 by 3 by 2. That's it.
Yeah, I get it, sir.
This 3 by 2,
Is
we
it
are calling it
reciprocal?
as k. Okay, ma?
Okay, sir.
That's it. We are not doing anything. We are just, instead of this, we are just calling it as 1 by n by r. Okay? That n by r, we are
Okay,
calling it as k. Then because
understood,
we
sir.
called n by r as k, n becomes kr. That is this. Okay?
Yeah, I know.
Okay,
Okay.
Okay.
sir.
So now this a power m whole power n, which is nothing but a power mn, we are just transforming it this way. Okay. Why we are doing all of this? Because we know this part is actually equal to e. We don't know about this part. We are trying to manipulate this one to express this expression in terms of e. So this one became what? E power rt. Agree?
Okay, sir.
Yes,
Agreed.
sir.
E power rt to get this, to find the limit. Okay. If you are given to find the limit of this expression, right? When let's say n tends to infinity, you cannot say it is e, right?
No, sir.
So let's say this expression limit n tends to infinity. Okay. What is the value of this? We cannot say e because if it is e, then it should apply only for this thing, right? So that's why we are trying to use this and we are trying to manipulate this a bit to get in this form. Okay, ma?
Okay, sir.
Okay. Now, see now when n tends to infinity, this one obviously this also will tend to infinity, right? N by r will also tend to infinity, right?
Yeah.
So that's why we converted this and we got this in this format. So actually the limit is this. Okay, ma?
Okay, sir.
Understood, no? Oh, okay. So now basically what we have understood is what is an exponential function, what exactly is e, and what is the significance of this part. Okay? This limit.
Okay,
This
sir.
limit is very important. Then this is a variation of 1 power infinity. Agreed? Indeterminate form. Okay.
Yes, sir.
Okay. Now e power x is an 1 function. We just figured out, right? Because it is a 1 function, it should have an inverse. Agree?
Agreed, sir.
Okay, so or forget
Agreed,
about e
sir.
power x. 2 power x, because it is a 1 function, it should have an inverse. 2 power x, it will look like this because there is an inverse. That inverse should look something like this, right? Mirror image with respect to this line, right? It
Yes,
should
Yes.
look
sir.
something like this. Okay. Now, what is that inverse function? That is this inverse function. Okay. Okay. Now, please read this
Okay, sir.
statement. Please read this statement. If x equals a power y, okay, then log x to the base a is y. Okay. This if and only if.
Okay, sir.
Okay. This is the definition of logarithm function. We discussed this earlier, right? 2 power 3 is 8. Then log 8 to the base 2 is 3. Right now?
Three.
Okay.
Yes, sir.
If log 8 to the base 2 is 3, that means it automatically means 8 equals 2 cube. Right? Now here something you have to notice. This a is positive. Okay. Okay. A has to be positive.
Okay.
Okay. And automatically x is also positive.
Okay, sir.
Okay, ma? Agreed?
Agreed, sir.
Okay. So now a power y equals to x. Please be comfortable with this notation. A power y equals to x, then log x to the base a equals y. Don't get confused. It is not log x to the base y. Okay. 2 cube equals to 8.
Okay.
That means log 8 to the base 2 is 3. Okay.
Okay, sir.
Okay. So that's how logarithms and exponents are related. Okay. Because basically they are
Sir,
inverses of
so
each other.
A is the base, sir, there.
What? A is the base.
Okay, sir.
Okay. Okay. Now convert this without looking here. Just tell me. Looking here and convert this. What is u?
25.
U is y square, right? What is 8?
Yes. Sir, 3.
One cube.
Oh,
8
wait,
is
it's 2, sir. It's 2, sir.
No, be
Sir,
careful.
2.
8 equals b cube. This
Okay,
one.
sir.
Agree?
Yes, sir. Agreed,
What
sir.
Okay,
about this?
sir.
Shreyas, clear, ma?
Yes, sir. I can hear you.
What about this
Okay,
one?
sir.
Tell me.
Hmm.
P power r equals q. Agree?
Yes, sir.
Yes,
What
sir.
about this one?
Sir, 4 power W equal to 2t plus 3.
Very good. What about this one?
Sir, 3 raised to 5 plus 2z equal to
X.
x.
Very good. Fantastic. Agree, no? Okay.
Yes, sir.
Now the reverse also you can do, no? Now without looking here, look here and tell me. Exponential form, convert this to logarithm form. 5 square equals to u. Now tell me.
So I need to convert to logarithmic form, yeah?
Logarithm form. Log u.
Sir, won't it be 2
Sir,
log 5?
log 525.
No, don't. You have to express log something to the base something equals something. Okay?
Yes, sir.
Oh,
You express it that way.
Base,
Log
no, sir,
something.
base is 5 and then the above one is 25.
No. Log something. What is that something? To the base something equals something. Okay? What? Express in this way.
okay.
Log. What
Yes,
is
sir.
this? Log u to the base 5 equals 2. Understood?
Understood, sir.
Be careful here. You express it again. Log u.
Log u,
No. To the base what?
5.
Base 5 should be equal to
Log u to the
Log,
base
sir,
5.
can you just repeat that again? Log
log
2 to
u
the base of
to the
5.
base 5 should be equal to 2.
Yes, sir.
Okay, sir. Log u
Tell
to the
here
base
log
5 equal to 2.
come
Sir,
tell
log 8 to the
base
base
Log
b.
8 to the base of
Log,
b.
log
b.
8
No, no,
to the
no.
base equal to
Right,
3.
Yeah.
log 8 to the base b
Okay.
is 3. Okay, ma?
3.
Yes.
Yeah.
What about here?
So
Sir, log
log q to the
q to
base
the
of p
base
equal
p
to
equal
r.
to r.
Log q to the base p equals r. Very good. What about here?
R. Sir, log
Log 2p
2t plus
2t
3 to the
plus 3
base
to the
4
base 4
equal to
equal
w.
w.
Very good. Excellent. What about this?
So
Sir,
log
log
x to the
x to
base
the base
3 to
equal to
equal to
5
5
plus
plus
2z.
2z.
Very good. Excellent, ma. Excellent.
Okay.
Superb. Okay. Now you are given something like this. Okay. Now, how do you express this as, again, can you try to express this? Log something to the base something equals something. So here n equals this thing. What does that mean? N by 1000 equals 2 power t. Okay. Now try
Yes,
to
sir.
express this. Try to express this in logarithms.
Okay, sir. Sir, we have to write it.
Just tell me. Just tell me. Log what to the base what equals what? Just tell me.
Sir, log.
Hmm.
One second, sir.
Be careful. If you want, you can write. You can write your
Sir,
two
can you repeat
cubic.
again? Can you repeat the
This
question?
this this one you have to express in terms of logarithms. See,
Sir,
this
so
is
will it be uh,
ah
n by 1000 to the base 2 equal to t?
very good, excellent. Log n by 1000 to the base 2 equals to t. Very good.
Yes, sir.
Okay.
That's it. Okay, so basically what we are saying, this n by 1000 is a. A equals 2 power t. Let's say log a to the base 2 equals t. That's it. Okay, ma?
Okay,
Okay,
sir.
sir.
Okay. Now that we have understood. Okay. Now you should tell me what is log 100 to the base 10?
10, sir.
No, it is square. 10 square is 100, right? It should be 2.
Oh, yes, sir.
Be careful.
Yes, sir.
Try
Yes.
this. 2 raised to
Sir,
what
it's
will
1
become
by 5.
1 by 2 raised to what?
1 by 5.
No, 2 raised to 1 by 5 is what? Is it 1 by
Oh,
32?
uh, sir, minus 5?
2 raised to minus 5. Very good. What you wanted was 1 by 2 raised to 5. Right? It is not 2 power 1 by
Yes,
5.
sir.
Right? No?
Yes, sir.
So 2 power minus 5 is 1 by 32. What about this one?
Sir, the answer is minus 2.
9 power half. Right. Or 9
Oh,
power
wait.
minus 2.
Sir,
Very good. What about this one?
sir, it's 0.
0. Very good. 7 power 0 is 1. What about this one?
Sir, I don't know, sir.
Whatever you do, you cannot get a negative number. So this is not defined. Okay, this part always has to be positive in logarithms. Okay, ma?
Yes,
Sir,
sir.
it's
3
not
raised to
defined.
whatever we discussed, no? 3 power x will look something like
Sir,
this.
so
Right?
log can never be negative. It should be only positive.
Log here. This part can never be negative. Okay, the result can be negative. See, here
Okay,
you
sir.
got the result as minus 5. Okay,
Okay, sir.
the result can be negative, but the domain cannot be negative. Okay, ma?
Fine, sir.
Okay, sir.
Okay, so here in this case it is not defined. This okay.
Yes, sir.
Okay.
Understood.
So do you
Understood,
agree
sir.
with this? Log 1 to the base anything is 0. Agreed? A power 0 is 1.
Yes, sir,
Okay.
agreed.
Now
Agreed, sir.
log a to the base a. What should this be? He is saying it is 1. Do
So
you
it should be
agree?
1.
A power 1 equals
Agreed,
a.
sir.
Okay. Now log a power x to the base a equals to x. Do you agree? Because a power x
Agreed,
equals a
sir.
power x. Agree, no?
Agreed, sir.
Okay. Now again, do you agree with this? Fourth statement.
Sir, can you explain it?
So log x to the base. Okay, take some number. Okay. Log 8 to the base 2. And 2 power this thing. What should this become?
Sir, 3.
No, log 2 power 3. This becomes log 8 to the base 2 is 3, no?
Yes, sir.
Yes, sir.
And this becomes 8, no? That is this number, no?
Yeah, sir.
Basically, 2 raised to what power will give 8? That is 3. Now you are actually raising 2 raised 2 to that power. So obviously you should get 8. Agree, ma?
Agreed, sir.
Okay. Please convince yourself again. 2 raised to what power will give 8? That is some power. Okay. Now you are actually raising 2 to that power. So obviously you should get 8. Agreed?
Okay, sir.
Okay.
Agreed, sir.
So now see what he is saying. The fourth one. Fourth one. See, this is what he is saying. Y is log x to the base a. That means 2 raised to what power? 8 raised to what power? Sorry, 2 raised to what power will give 8. That is this y. Okay, now we are actually raising this 2 to that power. Okay, ma?
Okay, sir.
Agreed, no?
Agreed, sir.
Okay. Now, exponential functions are 1, 1. Similarly, logarithm functions are also 1, 1. Obviously, right? Because this is inverse of that. If that is 1, 1, this also should be 1, 1. And both are inverse to each other. Okay. We discussed this, right?
Okay,
Okay. This a power x, the inverse of a power x should be log x to the base a. Okay. A power x, inverse of this. Okay. That should be equal to
okay,
log x to the base a. Okay.
okay, sir.
Understood? No? This part you are clear now?
Yeah,
Okay.
sir.
Okay. Now, what does this mean? 5 plus x equals 4 cube, right?
Yes, sir.
This means that you can do. Okay. What does this mean? X equals 3 power y. Okay. Or y
Okay, sir.
equals log 3x. Y equals 3 power x is this graph, and this log x to the base 3 is actually inverse of this graph. Okay, ma?
Okay,
Okay.
sir.
Now, we'll discuss some important. Okay. Okay. Uh, uh, just look at this graph. F of x equals log x to the log mod x, absolute value of x, to the base 3. Okay. Please notice here, when x is greater than 0, that is this graph. Agreed?
Yes, sir.
Okay, that you all agree, no? When x is less than 0, obviously, now see here, this is an even function, right? Even function, because minus x plus x, it doesn't matter. The result is still same. Right? Even function, we know it is
Yes, sir.
symmetric with respect to y-axis, right now?
Right,
So
sir.
that's why it is symmetric with respect to y-axis, and the graph looks something like this. Okay, ma?
Okay, sir.
Okay. And you agree with this graph also, no? This graph.
Yes, sir.
Inversion with respect to y-axis. When x replaced with minus x, it is reflection with respect to y-axis. Okay?
Sir, but
Uh,
here there's no modulus, so it's supposed to go downwards here.
what, ma?
Sir, there's no modulus. Previous one there is modulus, but this one there is no modulus. So
Very good. So
isn't it supposed to
we
go
discussed now
downwards?
f of x versus f of minus x. F of minus x is what? Just reflection with respect to y-axis, no?
Yes, sir.
Okay, here, here it is not just reflection. The graph is valid for positive x, negative x, right? In this case,
Yes, sir.
it is not valid when x is greater than 0, because this becomes negative, right? This is
Yes,
valid
sir.
only for
Yes, sir.
x is less than 0. Okay, ma?
Okay, sir.
Okay, so now other important things. Okay, uh, the properties of logarithms. We'll get to the properties of logarithms. This and all you agree, right? This you agree.
Yes, sir.
Okay, now we'll get to properties of logarithms. One second. Okay. So he's saying there are different properties. Okay, some simple three properties. Okay. Okay. So now first, do you agree with with these statements? You know these statements, no? Now I think today you're told about these statements, no?
Yes, sir.
Yes, sir.
Okay. Now let's understand why exactly this works. Okay, why exactly this
Okay, sir.
works. Okay. Now let's take this one. Let's take r equals log u to the base a. What does that mean? U equals a power r. Agree? Do you agree with this statement?
Agreed, sir.
Okay.
Yes, sir.
Now what will u become? U becomes a power r, a power s, right? A power r plus s, right? Now, what will log uv to the base a? It should be r power s, no?
Yeah,
Agree?
sir.
Log uv to the base a is r plus s, right? But what is r? R is log u to the base a, right? And what is s?
Yes, sir.
Log w to the base a. Agreed?
Agreed, sir.
Okay. Now, what I suggest is you do the same proof. Okay, you do the proof and tell me that you got the same result or not. Just take a minute and you do the proof.
Sir, like what?
Right now, just do the proof on your book. The same proof that I have told you, no?
Okay, sir.
Because you'll very easily forget this because you're doing it for the first time, no? It is
Understood,
important
sir.
for you to prove this. Okay? You just assume u equals a power something, w equals a power something. Okay?
Okay, sir.
Okay. So in this case, he has assumed u equals a power r, w equals a power s. You can use any two random variables also. That doesn't matter. U equals a power something,
Okay.
w equals a power something,
Sir,
and
I can take it as A or B also, right?
it doesn't matter. But here the base is a, no? That's why rather stick to a.
Okay,
Understood?
sir.
So log u to the base a is something, right? Let's say if you
Yeah.
say log u to the base a is, let's say t, then what does that mean? U equals a power t, right?
Hmm.
So assume this as something and this as something. Then express u in terms of that a and the other thing and try to derive this. Okay?
Okay, sir.
Just take a
Okay, sir.
minute. It's easy, but still I want you guys to do once. Okay, otherwise I will show you this thing also. You prove it without using the same variables. I mean, you use some other variables. Don't call R and S. Let's say you call T and V or something. Okay?
Okay, sir.
Okay, sir.
Okay. No, you use the same idea, but don't use the same variables. I want you guys to do yourself once.
Fine, sir. Do it now. Sir, so we can change everything except the base, right?
Yes.
Okay, I'll keep the base same then.
Sir, so we just have to convert the logarithmic form to
Yes.
exponential form. That's
Sir,
it.
can you scroll down once? Okay.
That's it. Till here is only the proof. So,
Not the proof, sir. The question I want to see
question,
what
question.
variables they took.
Okay, okay. What you have to prove is you have to prove this thing. We can prove
Yes, that's
something
all.
similar also. Log PQ to the base, let's say Z, equals log P plus log Q with Z. Something like this. Basically, what we say is log xy equals log x plus log y. Log x by y equals log x minus log y. Okay, so these three are very, very, very important. That's why
Okay, sir.
you should actually
I'll do
know
that.
how to prove this also. So the proof is nothing. It's just basically converting into exponential form. That's it. Then it's automatic.
Okay, sir.
Got it, no?
Sir, one
Yeah,
second. I'm still doing.
getting it now.
Yes, sir. That's all.
Done, no?
Sir, one second.
Hmm.
Sir, how do you do the last one though? That's
The second one
quite.
is also done.
Sir,
Yes, sir.
I
First
finished the
one, fine.
first one, sir.
First one, it's.
Yes, sir.
Okay.
First one even I did.
First one you are done. Okay. Second one also same thing. Let's say if you call
Yes, second one is also fine, sir.
u equals a power x and w equals a power y. What is u by w? It becomes a power x by a power y, a power x minus y. Right?
Yes, sir.
Now log u by w to the base a. What is this? Obviously it is x minus y. Right?
Yes, sir.
Great. And what is x? X is log u to the base a and y is log u to the base w. Right?
Yes, sir.
Minus log u. Uh, sorry, log w to the base a. That's it. Okay, ma?
Yeah.
Understood, no? This is the same thing.
Yes, sir.
Similarly, the third one also you can do the same thing. See here. Third one, just convince yourself. He's saying
Yes,
u
sir.
is again a power r. What is u power c? A power r whole power c. That is a power cr. And
Okay.
log u power c whole to the base a. That should become what? That should become cr. What is r? R is log u to the base a. That's it. Okay, ma? Do you agree with
Sir,
this?
sir, how did R become log A, log U to the base A?
That is our original definition, no? Okay, u is a power r, right?
Yes, sir.
Okay, then what log u to the base a is what? That is r, no?
Yeah, sir.
That's it. That's what he has used.
Oh, that's why. Okay, sir.
So our initial definition itself is u equals a power r, no?
Yeah, yeah.
That's it.
Okay,
You
sir.
In
write
the A power R, he put it in logarithm form. That's it.
yes, that's it. A power r, you convert it to logarithm form. That's it.
Okay, sir.
Then you express r in terms of u and a. Anything you can express in terms of the other two things, no? If you want to express u in terms of a and r, it will be in exponential form. If you want to express r in terms of u and a, it should be in this thing. It should be in logarithm form, right? If you want to express a in u and r, you will write it as a equals u power 1 by r, right? So these two will be exponential forms. This one will be logarithm form. Okay.
Okay, sir.
Okay. So now we have figured out, we understood that these three cases, how we actually derived. Okay. Now this one. Okay. Here we have this automatically means this is to the common base, right? So here whenever we say log u w equals log u plus log w, that means the base is actually common for all of these, right? So for example, here A, here A, here A. All three are same. Okay. So that's why sometimes we drop, or rather we'll say it is understood. Okay. That's why we don't explicitly mention that it is A, etc. Okay.
Okay, sir.
Okay. Now, but sometimes instead of taking a base, we directly write it as natural logarithm. What does that mean? The base is actually equal to E. Okay. That 2.7
Okay.
irrational number. Okay, ma?
Okay, sir.
Okay. So please be careful.
The-
This will not hold. Okay. It is log uv
Yeah.
equals log u plus log uw equals log u plus log w, but not this one. Okay. Okay.
Okay, sir.
The difference will come when it is u by w, not u minus w. Okay.
Okay,
Okay.
sir.
So for example, now we want to expand this. How will you expand? Tell me. Okay.
Sir,
So
it's
see first
sir,
log.
it's log a x cube y raised to half minus log a z square.
So log z square to the
It's
base a.
basically
Okay, ma?
log a by b is equal to log a
Log a
minus
by b
log b.
equals log a minus log b. That's what he has done first. Okay.
Yes, sir.
Now log ab equals log a plus log b. That's what he has done.
Yeah, yeah.
Okay.
Yes.
Now log a power m equals m log a. Okay.
Okay, sir.
Okay. So you understood, no? Shreyas, you are also clear, no? How to
Yes,
expand
sir.
logarithms?
Oh,
Okay. Okay. Now what you guys do? You take this one and contract and try to get this one. Okay.
Okay, sir.
Okay. Just try take this one and try to get this one.
Okay, sir. So we just have to reverse it.
I just have to reverse it. Just do that simple calculation and see you are getting the same result or not.
Got it, sir.
Got it now? Very good.
yes,
Yes,
sir.
sir.
Even I got it.
Okay. This one, just contract it and tell me.
Okay, sir. 1 second, sir. Got it, sir.
Got it, no? Okay, very good. You can solve these kind of equations, no? So, for example, log a
Sir,
plus
now we
b.
need to solve example 3.
No, no, you understood, no? You can solve it
Yes,
Yeah,
later.
sir.
yes, sir.
Okay,
So
so
I
what is
make some
saying? Log
variance
a plus
6%
log b is
reduce
log ab.
percent.
His so log, and because it is 1 1,
2x
right?
plus 3 equal to 33. Yes, sir,
2x plus 3
understood.
equals 33. Okay, that's
Yes,
it.
yeah.
Okay, so similarly, x into x plus 2 should be equals 3. That's it, right? No?
Yes, sir.
Okay,
Yeah,
so 2 into 2 plus 2. Okay, this is just checking. That is fine. This one, x
checking,
plus
checking.
6 by 10 should be equal to x minus 1 by 2. Right?
X plus 6 by x minus 1.
Yes, sir.
Right?
Yes, sir,
Or
yes, sir.
he has actually
10 by
sent
2
it
and
this
x
side.
plus
X
6
plus
by
6
x
by x
minus 1
minus
and
6
10 by 2.
equals 10 by 2. Okay, ma? So
Okay,
these
sir.
kind of things you can do. So 3 power y equals 81x. Okay,
Sir,
or
when do
here's
they actually teach the logarithm chapter?
what,
Usually.
ma?
Sir, when do they have to teach the logarithm chapter? Usually in
This
10th
no,
grade.
no, this is very basic. I think in class ninth or 8th it should be done. It's actually very, very fundamental. So the graphs and all they will not teach. What you should be taught is these ones basically. A
They didn't
logarithm
teach
is
anything
as
else,
an
sir.
exponent and these formulas and these basic
Sir, we
manipulations.
learned about logarithms for the first time today in school.
Right, right. This should have been in class ninth, I think, at best.
Oh,
Okay, these kind of
Oh,
manipulations. See, these are so easy, right?
yes,
yes,
sir.
sir.
So these
Very
kind of
easy.
Very
manipulations, this
easy, sir.
was in class ninth. Okay,
Sir,
fine, fine.
we
Whatever.
would have mastered if we
But
learned it before itself.
right, right. So, but they will not discuss graphs. Graphs will come in plus one only.
11th. Oh,
11th or at max
So
10th.
that we should be learning. That we should be learning by now. This one.
Right, right. That you should
yes,
be
sir.
learning by now. Fine. What happened? I also felt today's class is kind of extra class. I mean, I wanted to actually take you through some PVQs of this one continuity and differentiability. Because if I want, once we do PVQs, now I can give you some homework. I mean, at least repeat the same
Uh,
questions. Right. Otherwise, because
yes, yes.
daily you should be doing some kind of homework, right? Either
Yeah,
you
yes,
do
sir.
from Deepti, or if you want, I can give you homework, whichever way. What do you guys prefer? Should I give
Sir,
you
Deepthi.
Deepti? You will be able to do. But the thing in
Yes, sir.
Deepti is
Deepthi
you
will
should
be
be able
better.
to find the questions which we have covered. I mean, you should be able to recognize yourselves only, right? Which all topics we have finished.
That
Okay.
is also true, sir.
Sir,
That
in
that
Deepthi right now, barely anything, sir.
no. Deepti, what you
As
have
a
to.
whole, it's full of integration that we don't
No,
know.
I
Yes,
think
sir.
which book I think you have to pick the book
Sir, I
number one.
started off with, sir, I started doing a few questions. And right now, once again, sir, I'll tell you where I was. I was doing a few questions before.
No, Deepti, Hrithik, what happens in Deepti? Deepti, there is first year book. No, you have got 4 books, right?
Yes,
Yes,
sir.
Which one you have seen? I think you have to see in 1B that book.
Yes, sir.
Not.
Yes, sir. It's there in
oh,
junior
sir,
intermediate
I
syllabus
saw the second
1B.
year. I didn't see the first
No,
year.
don't see senior. It is there in junior inter 1B.
Junior intermediate second year, this thing, sir. Second year or
Second
something.
1B actually.
1B in junior year, sir. And
Yes,
I
yes.
started off with limits, sir.
Right, right.
I'm doing
Hrithik,
limits first.
Hrithik, you also
Uh,
should see junior inter 1B, not 1A. There
Sir,
you
it's
will
all
find
messed
these
up, sir. They're
problems.
saying senior intermediate, but there's all that permutations and combinations and all that, sir.
Right, right. No.
Sir,
Senior
sir, I
intermediate
checked
is
senior year 2B. Sir, I checked senior on 2B. That wasn't there.
Yes, sir.
that
You
that
should check
that won't
junior
be there. Okay,
intermediate
okay.
1B.
So the thing I'll tell you in this book, Deepthi book is based on AP board syllabus, AP state board syllabus.
Oh,
Okay,
oh,
whereas what you are following is NCRT, which is the national level
NCRT.
syllabus, right?
Yeah,
AP state board syllabus is different from this national board syllabus.
yeah.
These
Oh,
textbooks are actually preferred. The Deepthi books are preferred in Andhra Pradesh only,
Andhra Pradesh.
not across India.
Yes, sir.
Okay.
That's it. Even the people who published it also sound like Telugu itself.
They are all Telugu people only. The books are famous in Andhra states only, not beyond
Yeah.
Andhra states. So,
Sir, I started off with limits.
you start with limits, continuity, differentiability. Okay. So, what you
Yes,
okay.
guys
sir.
do is, whichever problems you are able to do, do. Okay. If you are able to understand the solution and still go ahead, that also you finish. If you are not able
Okay,
to
sir.
do, just skip it, then we will discuss. Okay. You have the
Okay, sir.
complete
Sure, sir.
solutions, but please target at least 50 problems in a day. These are 1 2 line problems only if you see. They're
Okay, sir.
not very big
Yes,
right
sir.
now. Shreyas?
Sir, I started off with 10 questions per day.
10? No, 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 no. I think you can, so 10 questions, how long you are taking? You'll do in 30 minutes or 10 minutes.
Sir,
Sir, but then,
beginner, yeah. So like it took like around
sir,
one
but
hour.
then for us, like we have other subjects also, yes, not only maths.
Oh, okay, okay, okay. Cool, cool.
That's why.
Okay, okay. See, these kind of problems we can do. Say, for example, these kind of problems,
Yeah,
no?
can I do like 10 questions for the
These kind of problems you
log
can do 50,
logarithm?
I'm telling. Right now?
Okay. Yeah, sir.
These simple problems. Okay. So, but start. Do some problems at least daily. Okay, ma?
Sure,
Or
sir.
Sure, sir.
what you should rather do is whatever problems that we have discussed in the class, no, that you should repeat once again. I am sending you the slides, no.
Yes.
At least
Yes, sir.
the ones which we have discussed, please don't miss. Okay. Right now, these are some slightly easy ones I am discussing, but once you get into PYQs, right, those ones you have to do
Yes.
mandatorily. Whatever we have discussed in the
Okay.
class, at least please finish them. Okay, ma?
Sure, sir.
Okay,
Sure,
I'll in
sir.
Okay,
some
sir. Sure.
problems I'll do detail, some problems I'll give
Okay,
hints,
sir.
and I'll ask you to finish the problems. Please do that. Okay, ma?
Okay, sir.
Okay,
Sure, sir.
cool, cool. You have class, or you can wait for a few minutes. You have class right
Sir,
now?
I
Yeah.
have class.
Ah,
They
okay, okay,
sent the
cool,
link.
cool,
Sir,
cool.
we have
Then,
class.
then we'll meet on Saturday morning. Right now?
Sure, sir.
Okay, man. Take care. All the best. Bye, bye.
Thank
Bye,
you, sir.
sir.
Bye, sir.
bye. Bye.